Planets orbiting close to the most abundant and longest-lasting stars in our Milky Way may be less hospitable to life than previously thought. This conclusion comes from a new study using NASA's Chandra X-ray Observatory and Hubble Space Telescope that examined the red dwarf called Barnards Star, which is one of the closest stars to Earth, at a distance of only 4.2 light-years. Red dwarf stars are much less massive than the Sun and are expected to live much longer lives. Barnards Star is about 10 billion years old, or over twice the age of our Sun. Astronomers already knew that young red dwarfs, with ages less than a few billion years, blast out strong bursts of high-energy radiation, like X-rays and ultraviolet light. However, scientists have known less about how much damaging radiation red dwarfs give off later in their lifetimes. The Chandra and Hubble observations were taken to help find that out. In March 2019, Hubble observed Barnards Star for about 7 hours and detected 2 ultraviolet high-energy flares. 3 months later, Chandra looked at Barnards Star for about the same amount of time and picked up a powerful X-ray flare. Based on the length of the flares and of the observations, the researchers concluded that Barnards Star unleashes potentially destructive flares about 25% of the time. If these snapshots are representative of how active Barnards Star is, then it is pumping out a lot of harmful, high-energy radiation into its surroundings, even at its advanced age. The team then studied what these results mean for rocky planets orbiting in the habitable zone, where liquid water could exist on their surface. They concluded the high-energy bombardment from a red dwarf of this age would erode the atmospheres of closely orbiting planets, reducing the chance of these worlds supporting life. This research contributes to the ongoing discussion among scientists about whether planets around stars other than our Sun are habitable. The team is currently studying high-energy radiation from many more red dwarfs to determine whether the behavior they observed from Barnards Star is typical